One of the most common asks I get from clients is, how do I build a custom AI chatbot? Well, a few months ago, this was something you needed to hire a consultant for. Today, that's not necessarily the case. In this video, I'll walk through 3 ways to make a custom AI assistant using a few new releases from OpenAI. I'll review a no-code solution via their new GPTs feature, a Python solution via the new Assistants API, and then finally talk about how to fine-tune an assistant with your data. And if you're new here, welcome. I'm Shaw. I make videos about data science and entrepreneurship. And if you enjoy this content, please consider subscribing. That's a great no-cost way you can support me in all the videos that I make. Before jumping into the solutions, I wanted to quickly differentiate a AI chatbot from an AI assistant. While these terms might be used interchangeably, the way I like to think about it is that a chatbot is an AI you can have a conversation with, while an AI assistant is essentially a chatbot that can use tools. A tool could be web browsing, it could be a calculator, it could be a Python interpreter, or anything else that helps augment the abilities of a chatbot. For example, if you have the free version of ChatGPT, that's a chatbot because it comes with a basic chat functionality without any additional tools. However, if you have the premium version of ChatGPT, that's an assistant because it has built-in tools like web browsing and document retrieval. Turning chatbots into assistants via tools is a powerful way to expand its capabilities and effectiveness. Each of the approaches I talk about in this video can be used to develop an AI assistant. And I'll use each of these approaches to build an AI that can respond to my YouTube comments in my likeness, which I'll call ShawGPT. The first way I'm going to talk about is the easiest and fastest of the 3. And it consists of using OpenAI's new GPTs feature. So the way to get to that is we go to ChatGPT, and if you have the premium version, you can go to this Explorer GPT thing here, and then you can go look at my GPTs. And so you can make these custom GPTs and they'll appear here. So I've already made a version of this ShawGPT, but we'll go ahead and create a new GPT so we can see what this looks like from scratch. The thing about this GPTs feature is it actually has a chat interface to help you build the AI assistant. So not only is this a no-code solution, it has a step-by-step chatbot that will help you build this AI. And so here, the GPT builder says, hi, I'll help you build a new GPT. You can say something like, make a creative who helps generate visuals for my new product, or make software engineer who helps format my code. What would you like to make? Make a YouTube comment responder. Let's see what that spits out. So you can see that GPT builder is thinking. What's happening is you say this to GPT builder, and then behind the scenes, it's going to go ahead and update the instructions for the AI assistant. So if we go to the configure tab, it'll start filling in these things. It'll fill in the description for the assistant and it'll give it its instructions. But let's go back. How about the name ShawGPT for this GPT? Does that work? That's perfect. Okay, so now it's going to generate a profile picture. So it'll use DALL-E 2, which is, if you're not familiar, that's a different AI that instead of generating text like ChatGPT, it generates images like this one here. So that's a cool thing about this GPT builder. It'll generate a profile picture for you. You can also just upload your own. So I've got a folder here called ShawGPT, and I've got some different images that we can use. So I'll just upload this one. And then I'll tell GPT builder to use this image instead. So it's going to use the picture that I uploaded. Okay, so now it's asking for a bit more guidance on how to answer questions outside the expertise in data science and entrepreneurship. So a lot of questions that I get on YouTube aren't actually about data science or entrepreneurship. It's usually people just saying great content or something like that, just sharing feedback about the video. So I'll provide those instructions here. Okay, so here I wrote out instructions for both positive and negative feedback. So for positive feedback unrelated to data science, express gratitude for their viewership, suggestions, or positive feedback. Given negative feedback, thank the viewer, rephrase their criticism to convey, not convert, convey understanding, and offer an idea for improvement. So these are just some general rules of thumb of how to respond to comments. How do you envision ShawGPT addressing comments that ask for personal advice on career changes to data science or starting a new business? Okay, so that's a good question. I didn't see this last time I made ShawGPT through this interface. Basically, when people ask me these questions, I tell them that there's no way to just give general advice to anyone without knowing more details. And ultimately, I only know what's worked for me, and I don't necessarily know what's the best choice for other people. And that's ultimately up to them. But I'm always always happy to kind of share my personal experience and what has worked for me. So basically going to try to put that into words so that GPT builder can instruct the model accordingly. So the way I tried to convey that is acknowledge that advice for their unique situation is hard to give without a full understanding of their situation. However, ShawGPT can share Shaw's personal experience in case it is helpful for the viewer. Okay, here we go. ShawGPT will now take the approach that when addressing personal advice inquiries. Okay, so for the final touch, what tone of language do you prefer ShawGPT use? More formal and professional, or casual and friendly? Casual and friendly and concise. I don't like reading a lot of text, and so I try not to put that burden on other people. So I like to keep text very concise. Okay, sweet. Feel free to try out ShawGPT in the preview and see how it responds. If there's anything else you'd like to adjust, what would it be? Okay, so we can now give it a whirl. How do I start in data science? So it gives a very long response. Doesn't feel very concise. Starting in data science is exciting. Here's a quick guide to getting you going. Learn the basics, explore online courses, hands-on practice, understanding data manipulation, diving into machine learning, build a portfolio, network and learn continuously. So it's casual, it's friendly, but it's not very concise and doesn't really sound like me. The response sounds a lot like what ChatGPT would say. So if someone reads this comment or response from me, they'll be like, did Shaw just copy paste my comment into ChatGPT and paste the response? So one thing we can do to remove that ambiguity is we can have ShawGPT sign off with its name, just so people know that it was generated by an AI assistant and not by me personally. We can add this to the GPT builder. Okay, so it updated the instructions. So now it should sign up as ShawGPT. So here's another one. Can you explain machine learning in simple terms? So it gave a pretty good response. I like this example, just learning by example and experiences. It signed off with ShawGPT, which is good. Again, however, the response is way too long. I would never respond like this, but it's good that it identifies itself. I want to move over to this configure tab. So I guess some weird things, even though it said it was going to use the name ShawGPT, that never made it over. It's still, I guess, in beta. They're still working out some kinks. If anything isn't what you want from this chat interface, you can always move over to the configure tab and just set these things manually. So you can set the name of the assistant. You can set the description. This was auto-generated, friendly and informative responder for a data science and entrepreneurship YouTube channel. And then these are the instructions that it generated through the conversation we were having. ShawGPT is the casual, friendly, and concise voice behind a YouTube channel on data science and entrepreneurship. It acknowledges the complexity of giving personalized advice, offering insights from Shaw's experiences instead. Positive feedback is met with gratitude, and criticism is handled constructively. ShawGPT always signs off its messages with its name, ShawGPT. So we can see like a lot of the aspects of the conversation were incorporated into the instructions. Another cool thing here is you can set these conversation starters, which is nice for the UI. You can just put like frequently asked questions for your AI assistant here. Another really cool thing about GPTs is that it has built-in retrieval, also called retrieval augmented generation. So basically what this means is you can equip your assistant with specialized knowledge that lives in like a PDF or like a Word document or whatever. So you can upload those files and the assistant will be able to read those files and incorporate the appropriate context as needed. So for example, I have a bunch of my articles here. So I could upload 4 ways to quantify fat tails with Python. I can upload that PDF and then I can ask it a question. What is a fat tail? It didn't use the PDF in this case. It just gave a standard definition of fat tails as something more extreme than a normal distribution, which is a common way of defining fat tails. However, it's not the definition of fat tails that I used in that article. So another thing we could try is like, how can we quantify fat tails? So even though it didn't use the definition of fat tailedness from that article, it did seamlessly grab the 4 ways to quantify fat tails from the article. The way this is working is that GPT-4 or whatever GPT is underlying these custom GPTs here, it has been trained to know when to seek outside knowledge if it doesn't know something. And so here it does it pretty seamlessly. It feels like it read the article and is like rephrasing it in its own words, which is pretty interesting. Okay, so that's knowledge. You can upload, I think, up to like 10 files or something. Actually, probably more. The next thing I want to point out are these capabilities. So this is what makes these GPTs assistants and not just chatbots. It's because it has these extended capabilities such as web browsing, image generation, and code interpreter. So web browsing is exactly what you expect. If the user says, hey, look up something or search the web for some resources or whatever, the assistant knows when to call upon this web browsing capability to do that. If the user asks the assistant to generate an image, it knows to use Dolly, and the code interpreter allows the assistant to not only write Python code, because that's what a chatbot can do, but actually run that Python code and then return the values to the user or use the values from that computation to inform the response to the user. So since for this YouTube responder use case, we don't need image generation because you can't have images on YouTube, probably don't need a code interpreter either. Web browsing could be cool to provide additional resources. And of course, I could upload all these other articles as well. So we can just do that to give it more knowledge. So we can't bulk upload PDFs at this point, but I can go through one by one and upload all of these articles to have it have a bit more specialized knowledge about the actual content that is on the channel. The last thing are these actions, which are pretty interesting. So essentially this allows GPTs to make API calls. So we can learn more here, how to create a GPT. Okay, so this answers one question. You can have 20 files uploaded. That answers that. Okay, here, custom actions. You can make third-party API calls available to your GPT. So that's pretty cool. Like the canonical case here is like if you want to grab weather data. So if you want to get weather from a particular city, you can endow the assistant with that capability to look up the weather in a particular city. Not necessarily for this YouTube comment responder. I think here just knowledge in the web browsing is sufficient. And so what's cool about these is you can save these GPTs and make it available to everyone. So you don't have to worry about like deploying your assistant into production because they have this built-in way to do it. So you can make it published only to yourself, anyone with a link, or everyone in the world. And then you can select a category. So that's pretty cool. It got the category right. We can confirm, but I won't because I've already published a version of ShawGPT and I spent a bit more time making that one. So I don't want to put this example version out there. But if you want to interact with ShawGPT, I'll put a link in the description and you can kind of see for yourself the performance. I guess another thing is people say like you can become a millionaire making a GPT or something. And I don't know, maybe based on my interaction with this interface, I don't know how that would work. However, looking at the other GPTs, this doesn't feel so much as like a direct way to generate revenue. However, it feels like a very big opportunity for these companies or really any company to do promotion and lead generation for their business. So like Canva being number one on here, it's like that's amazing advertising because whatever it is, they get 100 million daily users of ChatGPT. That's a lot of eyeballs seeing Canva basically for free. It feels more like an opportunity for these companies to promote their business. So like Alimon Academy, I don't know who that is, but I can just like go to her website. Look at that, Gen AI innovation for creatives. So look at that. Of course, this might be a way to generate revenue or whatever, but to me, it feels more an opportunity for advertising a business or something like that as opposed to direct monetization. So just my thoughts on becoming a millionaire with custom GPTs. Okay, so when it's all done and published, so this is publicly available, data scientist GPT for YouTube comments. And so we can have these things ready to go so people can ask their data science questions. Even though it has the articles available to it that I wrote, it doesn't explain it in the way that I explained it in the articles. It kind of gives a more traditional explanation of these things. So that's kind of one downside for these custom GPTs. It still feels a lot like ChatGPT, but just with slightly different wrapping paper. And of course, if I spent a lot more time with it, I could build something that doesn't sound so much like ChatGPT. But the second obvious downside of this is it requires a premium version of ChatGPT. And some people, just like a hobbyist or something, or you're like a student, it may not make sense to pay $20 a month for this. And of course, this isn't something you can easily integrate into like an app that you make or a website. For people to use this, they have to come to the ChatGPT website. So if you don't have premium or you want to incorporate this assistant into some application or some website, we can turn to the Assistants API, which is way number 2 that I'm going to talk about. So if you don't have a premium account, there's still a no-code solution for building a AI assistant, and that's through the Assistants Playground. This is a relatively new feature. So the Playground's been around for a while. This is the original version, the complete Playgrounds. You can pick whatever model you like here, and it'll just do the auto-regressive text generation. It'll just keep predicting the next word recursively. Chat is similar, where you can set the model and whatever whatever parameters you like and set the system message and just do like a chat. However, assistance takes things to the next level, where it's a lot like the GPTs configure tab that we saw earlier, where you can have a name, instructions, models, and then you can add tools to the chatbot. So we can really just copy paste all this over. So we have ShawGPT, here are your instructions. We can select the model, so we can have GPT-4 Turbo. We can add functions, so we can write custom functions here. It has to be in a particular format shown here. So you need to give it a name for the function. You need to describe it in words, and then you need to provide the inputs for the function. So what information does the assistant need to pass to the function in order to generate an output? It also has the code interpreter, so it can not only write Python code, it can run the Python code, receive a response, and then it also has retrieval like we saw with the custom GPT. The one thing missing here is web browsing natively. I think that's something that they're going to add later, but as of right now, it's January 30th, 2024. Web browsing is not integrated into the assistance playground or assistance API, but we do have functions, code interpreter, retrieval, and we can also add files like we did before. Let's see if we can do bulk file upload here. Aha, we can. There we go. Bulk file upload available in the playground. Okay, so we can just see how this works. We can do like a side-by-side comparison. So we'll ask ShawGPT, what is fat-tailedness? And we'll ask ShawGPT playground, what is fat-tailedness? Okay, so again, it's kind of giving the more traditional definition of something fat-tailed has heavier tails compared to a normal distribution. So the response is very similar to what we see over here in the GPT's case. So while using the playground to make an assistant in this way seems like a free hack, a free version of the custom GPTs, it has one serious limitation, which is that if you only use the playground, your assistant is trapped in the playground. It's not like the GPT's interface we saw earlier, where you can, with one click, deploy the assistant onto the ChatGPT website. So if you want to release the assistant from this playground, you want to put it into a website, an app, or whatever, you're going to need to do some coding. So let's do that. Okay, so here we got a Jupyter notebook. This is available in the GitHub repository, linked in the description below. So if you want this code, feel free to grab it there. Kind of walking through this, just importing some modules. Of course, we're going to use the OpenAI Assistance API, which is still in beta, so that's why I put that there. You'll need to import your secret key, and if you don't have a secret key or don't know how to get your secret key for the OpenAI API, I have a video all about that. I'll link it in the description below, maybe pop it up on the screen here so you can check that out. But you can get a key in a very straightforward way. You don't need to be a premium user. If you just have an OpenAI account, you can get an API key. And if you're new, you get some free credits to start. What I have is a text file called sk.py, and I'm importing the secret key from that text file. That's the way I like to do it. And also importing time for a helper function we'll see in a second here. The first thing we need to do is to set up the client. So set up communication with the OpenAI API. So you just do that with one line of code. I make a quick helper function because when we're using these assistants, they have to think. So it takes time for us to get a response from the API. So what this function does is waits and periodically grabs the status of the API call. And then when it's done, it'll move on to the next step of the code and it'll tell us how long it took to do that. So that's just like a helper function. It's not super important. This is kind of what we were doing before in the playground and in the GPT's chat interface, but now we're going to do it in Python. The first step is defining our instructions. So this is essentially the system message. So I'm using the same thing we had in the playground here. ShawGPT functioning as a virtual data science consultant on YouTube, blah, 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 blah. Just copy paste that here. And then we can create the assistant using this chunk of code here. The way this works is we created this client object earlier, and then we're going to be accessing the assistance API, and we're just going to use this create method. What that allows us to do is create an assistant, set its name, its description, its instructions, and the model that we want to use. Notice that this is everything we set here. The name, description isn't here, but you can set the description via the assistance API, the instructions, and the model. So it's all the same. And then I just print the assistant. Not that it gives us a whole lot of useful information, but it's just this object that looks like this. Okay, in order to talk to the assistant, you can set up this thread object, which is new in the assistance API compared to the chat completion API, which is what I talked about in a previous video. We can create this thread, which is just like a back and forth forth conversation. It helps avoid doing this boilerplate code of keeping track of what the system message is and what the user says and what the assistant says and what the user says and the assistant says, so on and so forth. It's all handled by the thread. So that's super convenient. You can generate the user message. So here I just put something like great content, thank you. So that's a comment. And then we can add this comment to the thread using this. So we have to specify which thread we're going to add the message to, which role is saying the message, and then the content of the message. We get the thread ID from here, role is user, and then content is here. Then finally, we can send the message to the assistant to generate a response. The way that works is you use this method here. So we're in the threads module, the runs submodule, and we're going to use this create method to create a run, which is just an API call essentially. So we'll need to provide the thread ID, which we just added this user message to, and we need to provide the assistant ID. And so where this comes from is the assistant object we made earlier. If we do that, we can run that, and then it'll take a few seconds to run. So that's why I run this helper function I made. And then once the run is complete, we can view that returned object. So it took about 5 seconds to do that first one. So actually we can just like run this whole thing. I think that's fine. Yeah, we'll just run this whole thing. All right, so it took less time this time. So it took about 3 seconds to run. So automatically when we do this run, when the assistant generates the response, it gets automatically added to the thread. So we don't have to do anything extra. So all we can do is grab the messages from this thread that was just updated by the assistant, and we can print the most recent message in the thread. So the response from the assistant is, "You're welcome. I'm glad you found it helpful. If you have any more questions or topics you're curious about, feel free to ask ShawGPT." It signed off correctly, which is nice. And it is a pretty positive response. It captures the sentiment that I convey. It's just super long. I never talk like this. Again, I don't like reading, and I don't want to burden people with just putting way too much text for them to read. I try to keep my responses pretty concise. Then here I just delete the assistant, because what happens is every time you make an assistant, it'll pop up here. And if you're running this notebook as just like a tutorial, or you're running it multiple times debugging or something, you're going to have a very long list of assistants here if you don't delete them. So that's what this line of code's doing. Okay, so we have this problem that it's giving nice responses, but these are just way too long. They don't really sound like me. One thing we can do to get ShawGPT to sound more like me is to give it some examples to learn from. So that's what I do here through so-called few-shot prompting. It's essentially where you put a set of examples in the instructions for the assistant. So these are real past comments and my responses to these comments. And all I did was append this ShawGPT to them, so it has that format we're looking for. And then we just do the same thing. We create another assistant in the same way. We name it ShawGPT. We give it a description. We give it the new set of instructions, which is what we define here. And then we define the model. Then we can create a new thread so we can talk to the assistant. We'll use the same user message, great content, thank you. We'll add the message to the thread. So again, specifying the thread ID, the role of who's saying it, and the message. Then we'll run the thread. So we'll send it to the assistant to generate a response by passing in the thread ID and assistant ID. And then we'll wait a few seconds for the assistant to generate a response. So it took about 3 seconds. And then here we're just printing the assistant's response. So this is what ShawGPT says now with the updated instructions to the same exact comment, which is, "You're welcome, happy to hear you found it useful, ShawGPT." So that's a lot better. I would probably have said just something like, "Glad it was helpful, happy to hear you found it useful." Maybe just one of these to make it a bit more concise, because you're just saying the same thing in more words. But this is a lot better than the original, and a lot better than what we were seeing in the playground with the no-code solutions. But of course, we could have added the few-shot examples in the no-code solution, and we would have gotten the same results. So another thing is technical questions, which ChatGPT might respond in a certain way, but it may not be the same way that I would respond to that technical question. So before we tried adding PDF versions of my articles so we could get the context of how I talk about fat-tailedness, for example, but for whatever reason, it wasn't capturing that. But now we've done this few-shot prompting, so let's see how its response changes. We're just doing the same exact thing as before. We're creating a new thread. We're generating a user message. So a new thread is as if we opened a new ChatGPT chat. So it's not going to remember this previous message. That's why we're making the new thread. Add user message to thread. So exactly what we did before, but now the user message is, "What is fat-tailedness?" And then we're going to send the message to the assistant. We actually don't need this here. I haven't gone through and cleaned up this code. Okay, and then we wait for the assistant to process the prompt. It takes a bit longer now, presumably because it's a longer response. It's not just like, glad you liked it. It's explaining what fat-tailedness is. And in fact, when we print the results, this is what we get. Fat-tailedness refers to a property probability distribution, which tails are fatter than those of a normal distribution. Okay, so it's just giving the same thing as we saw before. But notice that we haven't added any documents like we did in the no-code solutions. So let's do that. I quickly deleted the assistant so we don't have them piling up. Here's how we can add documents to the assistant. So the way that works is like this. So we go to the files module and just do this create method. So we just use this syntax, open, which is just opening a file. So it's creating a Python readable version of the file. So we're going to open the file. We specify the path, which is in this articles folder. This is just setting that we'll be opening this file for reading purposes as opposed to writing to it. We also need to specify the purpose of this file. So we'll say it's for assistance. The other option is for fine tuning, which we'll see here in a little bit. Once we create this file, it'll actually populate here, but I think it actually got deleted at the end of this notebook. So if you were to just run this chunk of code by itself, it's going to create a file in your files tab on your OpenAI account. And actually any assistant that you make can use these files for retrieval. All you have to do is provide the file ID, as we'll see in a second here. But notice where all these came from is when we were in the playground and we uploaded all 10 of these articles. With the file uploaded, we can create a new assistant that can access that particular file. So the way that works is we created this file object and now we can just pass it to the assistant. So this is the same exact method we were using before to generate the assistant. We set the name, the description, the instructions, but now we're going to define the tools. So here we're going to use retrieval as a tool. And when we do that, we also need to specify the file IDs of the documents that the assistant can use. So in this case, we're just going to use this one that we created up here. But of course, if you have a ton of files uploaded here, you can use all of them and you just need to specify all of the file IDs in this list here. And then finally, you specify the model. So now that we added retrieval, let's try the technical question once again. So this one took a lot longer to run, took about 45 seconds, but we're running it in the same way. This is interesting. It generated kind of like a mixed response, something close to what we were seeing before, where it's kind of giving a traditional definition of fat-tailedness. It's just more fat-tailed than a normal distribution. But then it's bringing in concepts from the articles that I provided, which is, fat-tailedness ranges from thin-tailed to very fat-tailed, which is almost verbatim from the article. And then it adds these 4 different ways to quantify fat-tailedness. And then it kind of gives some context. These methods offer different insights into distribution's shape, allowing for more detailed understanding of the data's behavior, especially regarding the occurrences and impact of rare and extreme events. ShawGPT. Yeah, that's pretty interesting that it added in those 4 heuristics and gave this dichotomy of thin-tailed versus fat-tailedness, which is something I talk about in the article. And then finally, I delete the assistant and delete the file. If you're running this multiple times, you don't accumulate a bunch of files and assistants on your account. And then some more resources. I'll put all these in the description. You can read more about the assistance API just from like a high level. The documentation, which is the API reference, breaks down the Python side of things. And then finally, more on tools. So here we just used retrieval, but there are 2 other tools that you can use, which are the code interpreter, which we saw in both the playground and the GPTs, and the functions tool, which is something we saw in the assistance playground. So just going back to that, we only used retrieval here, but we could have also used the code interpreter and functions. So if you want to read more about that, I'll provide this link in the description. Kind of talks about the tools, talks about the code interpreter, which, as it says here, allows assistance API to write and run Python code. So that's on the code interpreter, reading images and files. Okay, that's cool. And also have the input output logs. That's cool. Knowledge retrieval, which is what we did in all the different examples I talked about here. And then function calling. So this is the cool thing, and you can almost have any function with this capability. So the way this works is you need to give the name of the function along with a natural language description. And then you need to also provide a so-called JSON schema, which essentially outlines what the inputs of the function are. So the assistant knows what information to give to this function in order to get a response. At this point, we've seen both no code and Python ways of generating an assistant. And we saw that that we can get pretty far by using things like retrieval and few-shot prompting to improve the assistant's performance. However, there's still something missing from the assistant responses. It just doesn't really feel like something I would say. It's very verbose and doesn't quite explain things how I would explain it. So to kind of better capture this feel aspect of the assistant's responses, let's turn to fine-tuning the model. Unlike the Assistants API, there's no code solution for the fine-tuning bit. You have to write some Python code to fine-tune the model. And it requires a bit more work because in order to do fine-tuning, you need to curate a training data set. So here I'm going to kind of walk through the process of how I did that for this YouTube comment responder use case. Here's another Jupyter notebook. Example code is on the GitHub repository, so check it out if you like. Here we're importing some modules, again, importing the OpenAI Python library, importing the secret key in the same way that we did in the previous example, and then here importing a few other libraries that we're going to use for the data preparation. So again, we're going to set up our client, and then we're going to need to prepare the training data. So this is what makes fine-tuning a lot of work. It's just acquiring the right data. And a important rule in machine learning, if there are any rules in machine learning, is that data quality is the most important thing. Not how fancy your model is, not how efficient your code is, but how good your data is at capturing the thing that you're trying to model. And so in this case, what I did was I went to my YouTube channel and I took real comments that people left and then real comments that I responded with to create this input-output pair. So what that looks like is this. So I got about 60 comments and responses just copy pasted into this numbered sheet. I use numbers because I'm on Mac, but you could use Excel to just copy paste it in there. And then I exported it as a CSV file just to see some examples of this. Comment was, this was a very thorough introduction to LLMs and answered many questions I had. Thank you. To which I said, great to hear. Glad it was helpful. Smiley face. And of course we can have emojis in here. This one says Mr. Moneybags over here, which was funny. So these are just real world comments, which we incorporate into few-shot prompting, but you just can't fit 60 comments and responses into your assistant's instructions. And if you do, it's just going to create this like bulky overhead because the instructions are going to be passed to the assistant every time a thread is initiated. So you can imagine that the API calls are just going to become more costly over the long run if you just have a really large instruction set. And so that's where fine-tuning is helpful. And in fact, OpenAI has a nice guide on fine-tuning. Here we go. Common use cases. So I'll also put this in the description. Some common use cases when fine-tuning can improve results, setting the style, tone, format, and other qualitative aspects. So that's the main motivation for using it in this use case. Another one's improving reliability at producing the desired output. Next is correcting failures to follow complex prompts, handling many edge cases in specific ways. So I guess that's good if there's like a specific prompts or specific situations where the assistant is failing, you can just include those in your training data set and it'll learn how to not do that. And then performing a new skill or task that's hard to articulate in a prompt. And so I like how they put it here. The high level way to think about it is you want to fine tune when it's easier to show, not tell. Kind of like how I was experiencing in the initial no code GPT solution. It was asking me these questions and I wasn't necessarily sure how to give the best instructions. That's another downside of these no code solutions is that even though it doesn't require us to write Python code, it may not be obvious how to give good instructions using natural language. Showing, not telling is just a better way to convey the desired behavior of the assistant. Going back to the training data prep, we have all these comments and responses in the CSV file. However, the fine-tuning API doesn't take CSV files as input. The data need to be in a very specific format, which they talk about here, data preparation and analysis for chat model fine-tuning. And basically it wants the examples, the inputs and outputs in a JSON-L format. So basically it wants it in a text file. Here's an example. It wants it in this format where each row is an example and it consists of a system message, a user message, and then an assistant message. And each line is in the JSON format, which you can essentially think of as a Python dictionary. What we need to do is take the CSV file from here and translate it into the proper format in order to use it for fine-tuning. The way that works here is I initialize these lists to hold all the comments comments and all the responses. Then I open the CSV file. This is the CSV file, YouTube comments.csv. In read mode, this is like a common syntax for reading text files in Python. Not entirely sure how it actually works, but it's something I've used a lot, so maybe I should figure out how it works. But anyway, my understanding is that it handles the opening and closing of the text file, but if someone knows better than me, drop it in the comments below. I'm curious. So the first thing we do is use this csv.reader method to read the file. And then what that allows us to do is go through the CSV file line by line and just grab each chunk of text. So we're doing that in this for loop. And then we're actually going to skip the first line because as you can see here, the first line says comment and response. So what I'm doing is if the first element of the line is equal to comment, to just skip that line. That's how I'm skipping the first line here, but this will probably be different if your first line isn't comment and response. With that first line out of the way, the for loop will go to the next line, which is this comment and this response. And then what I'm going to do is append the comment to the comment list and then append the response to the response list, but also appending this ShawGPT sign off to the response so we get that desired behavior. And of course, you can do whatever string manipulation you like here to ensure that the output format of the assistant is whatever you like. So here I just have like a simple thing that I'm adding to it, but if you want it to be in like a JSON format or you want it to have like a particular format, you can do whatever string manipulation you like to ensure that it has that format. So this will just go all the way through the CSV file, just grabbing each comment and each response. So we do that, it'll save all the comments to the comment list. So that's what this is. And then it'll have all my responses here, or should I say all of ShawGPT's responses here. And so that's what that looks like. You can see emojis and all. Okay, so all we did right now is just put all the comments and responses from the CSV file in a list. We haven't actually made it into this JSON-L format. So in order to do that, we go to this next cell where we define our instruction string and we generate each example line by line. So the way that works is, again, going back to this example here, each example is a dictionary. So it's this key value pair where the key is always messages for whatever reason, and then the value is a list, which is this list here. However, the list is a list of dictionaries. So it contains 3 dictionaries, the first one corresponding to the system message, the second dictionary corresponding to the user's message, and the third dictionary corresponding to the assistant's response. That's the goal. That's what we're trying to do here. And so the way I do it is define the system message just once. Then I just go like index by index through the comment list. We go 0 to 58 through the comment list because there are 59 elements. And we just generate each of these 3 dictionaries. We generate the system message, we generate the user message, and then we generate the assistant response. And so that's what we're doing here. So role system content is always going to be this instructions string. Then we have role user. The content is going to be the ith element of the comment list. And then we have the assistant role and its content is the ith element of the response list. Okay. And then we just take these 3 dictionaries, put them into a list, and then we create a dictionary. I kind of do 2 things in one step here, so sorry if it's unclear, but we take this list and create a dictionary with the key is messages and the value is this messages list. And then we append this dictionary to the example list. So it's matching this format here where each line of this text file is a JSON format. So it's essentially a dictionary. And in the same way, each element of this example list is a dictionary. Okay, so there was a issue with this line of code, which I just fixed. But what we're doing here is we're going to create our train test split. We're going to designate a set of examples for training, and then we're going to designate another set of examples for the validation data set. And so the way I do that is I randomly generate 9 integers between 0 and the number of examples minus 1. And then I use those indices to create a new list for the validation data set. So this is just creating a list here where it's going to go through each index in this index list here, and it's going to copy that example from example list and put it into data validation list. And since these examples will still be an example list, we can go through and iteratively remove them in this for loop. So now at this stage, we've got 2 lists. One is called example example list, which is a list of dictionaries that have the data in the proper format. This should have 50 elements. It does. And then we have validation data list, which is just all the examples in our validation data set. And so this is also a list of dictionaries. And then we write these examples to two different files. So the first one is for the training data, and the second one is for the validation data. And so kind of in a similar way as before, we're opening this text file, specifically a JSON-L file with the write flag on, and then we'll just go through each element of example list and dump it into this JSON file, and then we'll do a new line character. So it creates a new line for each example, and then we'll do the same exact thing for the validation data set. And so once we do that, it should create these files here, training data.jsonl, validation data.jsonl, and then we can upload these files to the OpenAI API for fine-tuning. The way you do that is very similar to what we saw in the previous notebook when we were uploading the article for RAG purposes, for retrieval purposes. So we just use this files.create method. We open the file, which we just saved, but now we set the purpose as fine-tune as opposed to assistance. Do that for both the training and validation data. I just put that there so it didn't run the job prematurely. And then we can just run the fine-tuning job. So the way it works here is we specify the training file, the validation file ID, which is just a property of these two objects. We can set a suffix, which is basically some unique identifier or some identifier we can put into the name of the fine-tuning job or name of the model so we can identify it. And then we can specify what model we want to use. So GPT-4 is not available for fine-tuning. The most state-of-the-art advanced model for fine-tuning available is GPT 3.5 Turbo. So that's what we're going to use here. And then we can just run this and it'll create this fine-tuning job. And then if we go back to our OpenAI account, click on this fine-tuning tab, we can see this fine-tuning job is running. And so this actually kind of takes 15 or 20 minutes. It's not something that runs like immediately fast, but I did this yesterday, so we can just use this model. It's kind of like the cooking shows, like we already cooked the pasta last night, we're going to eat it in front of you. And so, yeah, it's already set up here. So fine-tuning job's running. Once it finishes running after like 20 minutes or so, we'll be able to use it. Another thing about fine-tuning is that your fine-tune models don't integrate into the assistance API. They only work with the chat completions API, which means those tools that we could include like retrieval, like the code interpreter, like the functions, which we could just easily add to our system by specifying some keyword argument. That's not available natively through the chat completions API. So if you want to add RAG, you want to add tools, you got to build out that functionality yourself using Python code. And of course, you can use like LangChain or Llama Index or some Python library to do that, but it's not integrated into chat completions. I'm sure at some point the fine-tuning models will be incorporated to the assistance API, but at this point, it's not available. Okay, so we're going to throw in a test comment. So we specify the model, and then we have to define the messages like this. So we define the system message using the instruction string from before. Then we pass the user comment just like that. Then we can run that. And then ShawGPT just says thanks. It's more concise, I'll say that for sure. And I don't know if I've ever just said thanks to a comment, but this is a pretty brief response. Let's see what another response looks like. And so this is a comment that came in recently. It wasn't in the training data set. So let's see what the response to this looks like. So the comment was, I'm typing this after watching half of the video as I'm already amazed with the clarity of explanation, exceptional. And then ShawGPT says, wow, thanks for the compliment. That's pretty good. That is something that I would write. I was playing around with this yesterday and it gave like a pretty cheeky answer. I don't know if it'll generate that again, but I found that funny. It was something like, thanks for commenting. I hope the second half of the video is good. And it had some emojis in there and I thought it was funny. But now it's like generating responses that I would say. Oh yeah, here we go. This is something similar to what I saw yesterday. So appreciate the compliment. Hope the second half doesn't disappoint. So now let's see how it handles a technical question. Again, the fine-tune model doesn't have retrieval built into it. If I wanted to add retrieval to this model, I would need to use like Llama Index or LangChain or something like that to add it in there. So let's see how it handles this. Of course, it's not going to describe fat-tailtedness how I did in the articles, but it is giving a much more concise and closer response to what I would say compared to what we were seeing before, like this monstrosity without the fine-tuning. There you go. That's how you do fine-tuning. It takes a little bit more effort up front to get together your training data set, but honestly, it took me about maybe 20 to 30 minutes to manually copy paste those comments into the CSV file. Maybe another like like 20 minutes to write this script to prepare the training data, but you don't have to write this script. You can just bring in your CSV file and it should be ready to go. And then again, I'll delete the training and validation files. Hopefully that doesn't ruin the fine-tuning job, but it doesn't really matter. And then more resources here. I'll drop these in the description below so you can take a closer look at it. So OpenAI guide for fine-tuning, that was pretty helpful. All of OpenAI's documentation is super clean and easy to understand. Let's see, they have their API reference on fine-tuning, and then how to prepare your data for fine-tuning is also available here. So overall impressions of fine-tuning, I'm honestly pretty impressed. I didn't expect it to work as well as it did, especially because it only used 50 training examples. In grad school, if I wanted to train a good model, I needed 100,000 examples to train a good predictive model. But because of the power of GPT 3.5 Turbo, it's already a powerful model. Even fine-tuning with just 50 examples results in really good results. That's why personally I feel like fine-tuning is probably the biggest innovation that we've seen in machine learning, because if you can find the right base model for your use case and you can just tweak it with just a handful of examples, you can get really good results in a fraction of the time that it would have taken you to develop that model from scratch. Okay, so that's basically it. We talked about 3 different ways to build a custom AI assistant using OpenAI. We first talked about the no-code solution, which allows you to build an assistant pretty quickly without any Python coding. Next, we looked at the Assistants API, which gave us a pretty straightforward way of creating assistants using Python code, which we can take and port over to an application or a website. And then finally, we saw how we can fine-tune an assistant to dramatically change its style and really come away with something that has good performance. If you want to play around with the no-code ShawGPT, I'll provide a link in the description below. But if you want to interact with the fine-tuned version of ShawGPT, drop a comment in the comment section below and I'll be sure to respond with ShawGPT. Unless you explicitly don't want me to respond with ShawGPT, just let me know and I'll respond as myself. So I hope this tutorial was helpful and gave you an idea of which approach might be best for your particular use case of building an AI assistant. While OpenAI does currently have the state-of-the-art large language models for building these things, a natural question is, how could we build these types of AI assistants using open source solutions? So that's exactly what I'm going to cover in future videos of this series, where we're going to explore both retrieval augmented generation, or RAG, and model fine-tuning using open source models. And if you enjoyed this content, this is just one video in a much larger series on using large language models in practice. So if you want to learn more, check out the series playlist linked in the description below and in the comment section. And as always, thank you so much for your time and thanks for watching.